To review the March 6th lecture material and the sample exercise, I still need to post some of those samples that I go through as demos on there for you if you're interested. But here's just a screen capture showing some of the work we did with workspaces and workspace factories on March 6th. Remember, a workspace is a location of GIS data, be it a geodatabase, a file folder with shapefiles in it, are two common examples. That's a workspace, and a workspace factory creates a workspace. Whether you're creating a brand new workspace with shapefiles or you're using it to create a workspace that points to existing data. So a little bit of a reminder from March 9th. I think we did some of these, we did some of this lecture already. To review, in this code on the slide, we use the shapefile workspace factory class. That's a long word to create a shapefile workspace factory using the iWorkspace factory interface. And then from that workspace factory, this is a common way of getting at data. It has a method called open from file. And you can provide a path. Because it's C#, we need to use, we don't want C# treating the path as escape characters, so use double backslashes. So in this example, we're creating a workspace from the shape, or to point to shapefiles located in that folder that's pictured there. We did look at that on March 9th. And this reviews what I just mentioned, that where workspace factory and workspace is a creation relationship. We use the workspace factory to create a workspace. It's like the chicken and the egg class relationship, where the chicken creates an egg. Workspace factory creates a workspace. I'm pretty sure this is review. Once you get your workspace, we looked at, right at the end of lecture, a property called dataset names, and you'll use this in a variety of labs. Dataset names return, and this gets a little weird how they do this, returns an enumeration of dataset name objects using iDataset name. And that lets us loop through a workspace and get a list of shapefiles, in this case. Get a list of shapefiles that are in that workspace. So in the example like we did at the end, we already saw this. We're creating a pointer to that workspace, in this case this particular folder. There's shapefiles in the folder. I use the shapefile workspace class. And then I prepare an enumeration on the workspace using enum dataset name as the interface. And what we do here is to populate the enum dataset name, we use the method getDatasetNames on the workspace. Remember, that's case sensitive. It has an enumeration, two types of enumerations on one line, indicating what types of data sets we're looking for. And to keep this simple, I'm using the dataset type any enumeration that will return all shapefiles in the folder. And here's an example of looping through an enumeration list to get individual dataset names. So once we have our enum dataset names, and that is an enumeration or a list. It will be a list of data sets in that folder. We then create a single variable, this is a list, this is a singular object, iDatasetName, like we saw on the last slide. We initialize that by setting it to the enumeration.next here. And that resets it, and it'll set PDSN, in this case, to the very first data set in the list. And then once we get to that point, it's a while loop. We looked at while loops back at the beginning of the class, so we've used a few of them, I think. Again, a while loop. With a while loop, you provide a statement. The while loop will continue to run until the statement becomes false. So if we follow this, while the data set name is not null, so in other words, while data set name exists, this loop will run repeatedly. So in this example, I'm using the debug property in Visual Studio .write line, and I'm just writing out as text the name of that data set, first data set. Then within the loop, we issue another next. I've mentioned that a couple times already because I know that's important. I think I mentioned on the original slide, if you don't ever find a way to make that false, you'll have an infinite loop. If this statement never becomes false, this will run forever until you close your program or turn the computer off. So this line effectively goes to the next data set in the folder. We loop through it, writes the next data set. It keeps doing that. Once it gets to it's gone through all the data sets and gets to the last one, this will return null. Now the statement's false, and we exit the while loop. So it's just so this also serves as a review of a while loop. So here's our result. We wrote the results on the debug line. Here's a screenshot and catalog of all the different shapefiles in that folder, and this is where that while loop went through and wrote the name of each shapefile. So you could use this to write your own catalog application, sort of like you did in Lab 2 if you've done that yet, where you pick a data frame. Although that's reading from a data frame, not a workspace. But you could write something similar to Lab 2, where you pick a folder, and you could use this to give you an inventory of the list of files in a location, or you could use it to search for a specific location, a specific file in that location. So this could come in very handy. And again, it's the key interfaces in question are iWorkspace Factory and iWorkspace, which we talked about, and IEnum dataset name and iDataset name. And the latter two help us get lists of dataset names in an actual dataset. I mentioned this a moment ago. There is a filter on get dataset names, and I chose DT any. In most cases, I would choose DT any, but as you can see, you can do a variety of other enumerations. For something like a shapefile, in fact, another reason for using DT any is in many cases, that'd be the only option. With a shapefile, none of these other settings make sense. So you really would only be using DT stands for dataset type. You would only choose DT any if it's a shapefile. But if it's a geodatabase, you can see you might choose DT any to get anything in a geodatabase, or you could choose DT feature class. There's a lot of different things that can be in a geodatabase. There could be tables in there, mosaics, topology, and so on. If you're only interested in feature classes, that's where instead of DT any, if you're using a geodatabase workspace, you would choose Esri DT feature class. So that's an example, though I think in this course we'll stick to the DT any and shapefiles. There's an example for you of where you might want to do something above and beyond that. Any questions? So here, this is more useful if we don't know the names of the data sets. But if you do, and often you would, here's how we can get from the workspace directly to a shapefile. I'm pretty sure we did this too. So here, the first two lines are the same. Oh, we only did the first example. That's okay. So in this example, we're getting a workspace just like we did a moment ago, but we know exactly what the workspace entails. We know what shapefile we're looking for, and it's the shapefile states detailed. So from the workspace, there is a command, just open feature class, that lets us do that. So if you know the location, or if you know the name of the data set in your location, you can just simply get to it with this open feature class and give this the shape name. Second. Can I do this? I think it's gonna. So once we do that, a simple thing we can do with a feature class is a feature count. You could put a query filter in, which I've not put in. I just said null here. We'll learn about query filters, I think, next week. It lets you specify a filter or an attribute query on your data. So what this example just does then is shows you the total number of features in the feature class. And there's 52. Not 50, because of District of Columbia. I'm not sure why there's 52, not 51. It's a mystery 52nd state. Second here. do that example. Let's go in and we'll go into our Visual Studio application and add another button. I'll just continue to use the same March 9th demo. So I'm going to create an ArcGIS add-in component, a March 30th workspace. Doesn't matter. What's that? Also, I forgot to do this. If I disconnect some of the E&E drives, it makes it go a little faster. Forgot to do that again. So let's do a comprehensive workspace example and kind of bring together everything we did. And we'll use that add-in button that I just created. I'm going to go to my last button and copy in some of the using statements. We already have a lot of ArcGIS references in this project. So I'm going to get the current data frame. This is a review. We've done this a number of times. IMX document. PMX doc, and you can get the latest map document with this document property on ArcMap. We've seen that before. And I can go a step further right from that and get an object that represents the data frame. The next two lines are two lines we've looked at on several slides this evening, as well as on March 9th. We'll use Workspace Factory to access our desired folder. So again, we use the shapefile workspace factory class. We're now creating an iFeature workspace, which is a workspace for vector features. So we need to cast to that workspace. And I need to take a quick look to see if this is where the data is stored. I think it is. And for some reason here we always have to capture the Windows handle for ArcMap. Take a quick look. And I called it counties, okay. So now we have a workspace pointing at this. And there's an ESRI in there that doesn't need to be. Pointing at that folder. And once we have that, as we saw a couple slides ago, we can, if we know the name of the feature class, we can go right to that. So once again, open feature class method on feature workspace is handy if we know the data set is there. And I think I mentioned this last time, it doesn't hurt to still use a try block. You may think you know it's there, but it still might not be there. So use a try block to make sure, or otherwise test. We'll just go forward with it for the demo like this, but it's a good idea to test for the location, for the presence of the layer first. So where are we with this? We have the feature class now as PFC, and we got it. We worked with feature class before the break, getting it from layers in the table of contents. This is different to us. We've gotten the data without it having to be preloaded, which is significant. In Lab 2, when you did the desktop reporting tool, all those layers were preloaded into the data frame. That's one way to get it, but now you see how you can get to your GIS data without that. So we have the county shapefile loaded right from the workspace. Let's add it to a map. So what do we add? We don't add data directly to ArcMap data frames, we add layers. So we need to create a new layer. And if you remember, feature layer is a co-class, which means we can create a brand new layer out of scratch. I'll call the new variable newFL. And just to review, we're creating the new object with the iFeature layer interface, which is implementable by feature layer class. And then we use the new keyword, lowercase NEW. So this creates a brand new object of the type feature layer using the interface iFeature layer. So that is a brand new object that did not exist before this line. So what are we going to do from there? We have a brand new feature layer. We can give it a name. so it doesn't just appear blank. We did that, remember we did that a couple classes ago. So that's the name of the feature layer we'll get. Actually, one other thing I have to do, and I purposely didn't do this the last couple classes ago too, and I forgot myself, we need to assign the feature class to the feature layer. So here, what's on the slide actually, I didn't do it on the screen, and I should have. This is where we do that. So for the new feature layer, I'm saying the new feature layer has this data associated with it, which is the county's data we found in the folder. And then finally, we go grab the active data frame, use add layer on it, and give it the new map layer. So let's give this a try. Oh, it's open. Okay. Here's my March 30th workspace button. And there it goes. I clicked to it. It went. So you see, this is somewhat of a step forward from what we've done so far in the class. We went and found GIS data that wasn't there previously using feature class and added it to our map. Is there any questions? In the final part of the workspace lecture, we go to slide, and slide 10 shows what I just showed you. Here's an example I had suggested a couple slides ago, maybe. Rather than just assume, oh, I know my data set's there, you should test for it. Here's an example of using a try catch block. So we'll add that in there. We'll purposely make a mistake and see what happens. So instead of just assigning the one thing I'll do different. I'll create the feature class first, but I'll set it to null. So I'm creating an object container for this feature class, but I'm purposely saying that it's empty. So now, I'm going to put the search for the county shapefile in a try block. And to illustrate the point, I will misspell it. And now when I run this, this will be an example called a graceful bailout. And actually it won't be. So I didn't put return, where return just ends your program in C#. That's still pretty slow. I notice actually some of these machines are still pretty slow too, even with the upgrade. Isn't that good? They're still faster than the ones last semester. Marginally. So now, when I click the button, notice the catch blocks ran, and it trapped the error. So that's a more graceful way of exiting the program rather than just having it disappear. Sometimes, as some of you found, especially Lab 4 is bad about this, some of you ran into that, I know. If you misspelled a field name or something like that without a catch block, rather than, that's what you call an ungraceful exit. Sometimes ArcMap just vanishes, or it gives the ArcMap has caused a problem and will crash error message without any useful information. So that's an example of a non-graceful exit. And sometimes those of you that had that in Lab 4 found that sometimes ArcMap isn't very good at, unless you force it to, ArcMap is not good at providing user-friendly error debugging in many or most cases, unfortunately. That is the end of the section of the class regarding workspaces. Are there any questions before we move forward? We go into a whole other topic. I don't necessarily want to break yet, if it's okay. It's still early yet. It's only 7:45. So I'm figuring I'll continue now rather than breaking at this point, and we'll break a little bit later. But we will now switch gears completely and talk about symbology and rendering. How to create symbols, coloring, labeling, and so on in ArcMap. We're done with the workspace section. So you will first see, excuse me, this, what you see at the top of the object model diagram, and we're not going to make everyone go find that, I just took a screen capture, is this abstracted, and you'll see this general layout of class, and we've seen it over and over with the parent abstract thing and a lot of different specific types inheriting from it. Symbol is no different. We have an abstract called symbol with an I symbol interface that represents all different types of symbols that you could have in Arc objects. But nothing is just a symbol. There are subcategories such as line symbol. So line symbol is a specific child of symbol that represents symbols that are used to draw linear vector features from shapefiles or geodatabases. And notice, like we've seen in other hierarchies too, line symbol itself is abstract. They are specific subcategories or grandchildren of symbol under line symbol. And I'll actually maybe add some of these to show in ArcMap. It's a line file. Here's a line file of state boundaries, not polygons, but actually the state lines. You know, you go in, you've done this, you go in to edit the line symbol. This is what I mean. There's no such thing as just a line symbol. When you go in to change a line symbol, maybe you've come across this before, maybe you haven't. But notice there's specific subcategories in a line symbol, like simple line symbol, cartographic line symbol, and so on. These are the co-classes that actually contain the symbol objects. So they're a grandparent or grandchild to symbol. The line symbol's the father, sounds like Star Wars or something, and then symbol is the grandparent. So we'll be working in this class I think exclusively with simple line symbol for ease of keeping things moving. So these are ArcObjects classes that correspond to what I just showed you. We have simple, and this isn't just line symbols, these are all the classes that implement iSymbol, the grandparent interface. So we have simple line symbol, you see the others. These represent polygon symbols and point symbols and text symbols. Yeah? It's not just colors of dots and lines, but it could be a font type, font character size, and so on, and we will look at that here. The ones I boxed in red are the ones from my experiences that you'll use the most often. In a lot of cases, at least in basic mapping, maybe not as you get more advanced, but in many cases the simple symbol objects are sufficient for what you need. 90% of the time or more. So it'd be simple line symbol, simple marker symbol is a symbol for a point, simple fill symbol is a symbol for a polygon. I highlighted a couple others we might use. And text symbol is the class that we use for defining font and size and so on. So if we're going to create a brand new symbol, we'll use iSimple line symbol in this case. Note how we can choose the lines choices available in the enumeration. So in this example, we'll do one like this shortly. We're starting out creating a new simple line symbol. As I mentioned, we're going to stick to the simple ones here. That's what you'll most often use anyway. So the simple line symbol class has a property called style. And then here's a enumeration where we can pick style. Just because it's simple, it doesn't mean you're only restricted to a solid line. There's 7 different choices in the simple line symbol. A lot of times we pick solid. You might pick null. That means no symbol. But that's why would you define a line symbol with no symbol? You might want an out. You might be defining the line on the outline of a polygon, but not want it visible. No line. So you might pick null in that case. You can pick a dotted line, a dashed line. It's like Morse code here. A dash dot or dash dot dot. We'll stick with solid. But here, this gets a little tricky. Let me go back a slide to remind you how simple line symbol is the grandchild. There's also this line symbol parent that has 2 more generic classes on line symbols to it, color and width. So we need a cast so that we have 2 variables on this line object using 2 different interfaces. Because we want to use the iLine symbol more parent interface to define the color as shown here. So this is also the first time, and I hope I have a slide on this in a moment. I know it comes up a little while to define how we're going to set color too. So this is the first time we've done anything with color in our objects. So here, I've casted the iSimple line symbol variable to iLine symbol. I'm also creating a new color class object using iColor. Sorry, this starts to get a little confusing. There's a lot of different classes and interfaces to think about. iColor is the interface, and RGB color class is the class. So we'll define a color. RGB color classes, RGB colors are defined using the red, green, blue value. But in this case, I'm going to use and I'll demo this in just a second. There's a variety of ways to get colors. In this case, I'm going to use Microsoft System.Drawing namespace. It has a color translator in it, and from that you can pick a set 200 or something of named colors, like forest green, for example. There's a variety of, and I wrote this here too, I guess, a variety of different ways to use colors. I used the Windows System Drawing color namespace here, but there's also ESRI has their own classes in their namespace to get colors, and we'll see some examples of that as well. There's a number of ways to get at color. And then one more slide, and then we'll do the example. So this, we kind of talked about this in the class about help, but the style property of simple line symbol. If you recall, just a couple slides ago, I showed you the autocomplete, where the style property has a few settings, or a few different choices that you can pick from. In the help, if you click on that property and look at the C# line on there, it'll show you the enumeration there. ESRI simple line style. It's hyperlinked, so you can click, and then the help will give you a better description of the sub and different options for simple line. ESRI SLS solid. You can also just type 0. The line is solid, and so on. I'm going to add another component. I'll actually make it a line. I'm going to copy this from the last. I'm going to get the current data frame. I'm going to get the top layer. Since I'm getting layer, what did I do wrong? Oh. I need to cast it to iFeature layer from my layer, of course. So, just to review, I'm getting the top layer. I'm making some assumptions here that normally I'd want to test for. I'm making the assumption that it's a feature layer, vector layer, but I'm also assuming it's a line layer, which may or may not. I'll make sure for the demo that it's true, but that may or may not always be true. So just like in the slide, simple line symbol, I need to add a new reference. I think it's display. Did that work? Yeah. The symbology and rendering are in the namespace esri.arcgis.display. We haven't used that one much yet, so I need to make sure to add that to my using statements. And here's where we'll set the style. Notice autocomplete fills that in for me. Simple line style dot, and I'll choose solid as my option. We'll say cast to I line symbol, so we can set color and width. And we're going to cast the existing object to ELS. And now I have two variables looking at the same line using the two different interfaces. Create a color. As I mentioned, the interface is iColor. The class is RGB color class. In many cases in ArcObjects, you'll see, the interface is just the name of the class with an I in front of it, but here is where it's actually a little different. And so the iColor interface, Esri's iColor interface has a property called RGB, where you set the red, green, and blue values. We will do that using the Windows class. As I said, we'll system drawing color translator. I have to look that up. So we're using the Windows method to get the color. So system.drawing.color translator. The method's toWin32. And then under system.drawing, color dot, there's a lot of different properties there. We can choose from a set of predefined colors that Windows has for us. So notice it, dark olive green, fuchsia, olive drab, and so on. Find a good one here. I wonder what Gainsborough is. We'll find out. There's a color called Gainsborough. So now that we've done that, we can set the color property of our line symbol to my color, which is the property we defined here using this Gainsborough setting. And we'll set its width in pixels. In this case, I'll set a width of 4. And I'll actually leave that here for now. Wait a minute. Let's some of this I don't want to get to necessarily yet. I'll leave this the way it is. We'll come back to it. So we looked at this slide already. And now this leads into another fairly major topic that ties in with the symbology. Is we'll talk about elements. We saw that the symbols were in esri.arcgis.display, but a lot of the components of elements are in esri.arcgis.carto, which we've already used a fair amount. An element is what we use to add a graphic to a map, either in data view like we'll do now, or layout view, which we'll do right at the end of the course. So to distinguish elements from a feature class, These shapes are from a feature class. It's from a shapefile of state lines. If you go into your drawing toolbar and draw a shape using this toolbar, like just adding a point, that's an element. So if you add a rectangle that way, that's an element. Or even text. These are all elements on a data frame. So we'll learn about elements now. And hopefully this will illustrate for us the difference between an element and a feature from a feature class. So element is the abstract parent once again. We have two children and then there's the grandchildren. So all elements are divided into two trees in the family tree. A graphic element or a frame element. We will begin now talking about a graphic element, which is a line, pointer, polygon, text, and maybe pictures. So all those, I think I deleted them. Oh well. All those shapes I created were graphic elements. The rectangle and the text and so on. A frame element are specific. Graphic elements can be anywhere in ArcMap. It could be on a data frame or a layout. A frame element is specific to a layout. And it's something like a north arrow or a data frame or a legend or scale bar. Those are frame elements, and we'll do that at the very end of the lecture, in a month or so. You can see how they're kind of split into these two sections of the tree. We're going to talk now about graphic elements and save frames for later. So I'm going to create another add-in. Copy in the usings. Copy. That's good enough for now. And copy the first two lines to get to our focus map. We'll create a new simple marker symbol this time. We'll do a simple marker symbol class. So, and with I marker symbol as, or I simple marker symbol as the interface. We'll set its style. Notice there's a couple different styles in the symbol. I will choose, that doesn't matter. We'll make it a square. Another thing I'm going to do to simplify things, I'm going to add a using for system.drawing, that Microsoft namespace. And that'll simplify things. Now I can go right to color translator. And right to color and choose my colors here. And choose, I don't know, how about maroon? So we'll set the symbol. In this section, it's very easy to forget that, oh, I set a color, I'm all set. But don't forget to attach the color to the symbol. You'll see a couple other examples like that the rest of this evening, and I'll mention that again. It's very easy to forget because there's a bunch of different components. And we'll set a marker symbol. I'll make it a little bigger, of 12. So it's the symbol we're creating is a maroon square of size 12. So we have, write some of this down. There's a couple different components before we can create a symbol and put it on the map. We have the symbol, and what I've drawn here I would call it the blue symbol is how it looks. This example, a blue triangle. Symbol, how it looks. The element is the actual feature. So we'll create an element and assign it a symbol, but the missing piece that we haven't done yet that we're going to look at now is where does the symbol go? And that's the geometry. So we'll create an element, assign it a symbol to say what it looks like, a geometry, where does it go? Or what is its shape? That's simple for a point, but it could be a polygon. And then once the element has a geometry and a symbol, we add it to our data frame or our view. Let me switch back to the slide to kind of show what we'll do, and then we'll do that. So I mentioned this new element thing. I'm creating that now. I'm creating a marker element, and I'm also casting it to just use iElement. So I'll have an element using iMarker element, which is a point element. I don't know why they just don't call it point element. Marker is a point, and IE element, the parent. So this is the element. I'm assigning its symbol, this part of the puzzle here, to the symbol that we created on the previous slide. And here's where I'm assigning a geometry. For other exercises, we'll see how you can get the user click. For now, I'm just going to assign it a latitude, longitude, which will be pretty close to what this is in Western New York. And here where I'm assigning geometry to the element. I'm creating a point. We'll do this in a second, the demo. I'm creating a point at that location and assigning that geometry to our element. And then in the final step on this slide, I'm adding that element to what we call a graphics container. The active view of ArcMap, the focused map, has a property called the graphics container. It's a collection of all the graphics on the map. So when let's stop for a second, there's a lot of new things tonight. So if I draw this data frame has 3 things in its graphics container. It could also include text. So now this data frame has 4 things in its graphics container. So that's what a graphics container is. So now let's code that. So So create a marker element object. I'll use PME for marker element. And then I'll assign I'm assigning the symbol of the marker element to the symbol we created up here, the maroon square. And now I'm creating a second variable, PEE, which casts that marker element to use the interface I element. And then I'll use PE to sign. I'm getting ahead of myself. So we have the symbology set. Now we need to set the geometry. And we'll start simple, we'll get more complex as the class goes on. Huh. Oh, it's not up there. And to do that, I thought I had this namespace ready. The geometry is located in a different namespace, esri.arcgis.geometry. So, a point has a method called put coordinates. It's abbreviated put chords. It takes a longitude and a latitude. Or it could be a map unit. Here these are in decimal degrees. So these are longitude and latitude. And now we'll add the element and refresh the map so it shows up. And we do that not through focus map. You can do it with the active view property on your ArcMap document. We get its graphics container property and as a method add element. We give it the I element interface variable. 0 means that it's on top. You can send things to back if the elements overlap. But adding this 0 adds it on the top of the list, so it'll be on top of any existing co-located element. And because we've changed the view, we need to then refresh. Let me run this. Hmm. What is that? Adding it at the equator. What did I forget? Oh. Didn't I say I would do this? I never assigned the, see how easy it is to forget that? I never assigned the geometry. So I was mentioning that earlier. I created a point, never attached it to anything. It's very easy, as I just illustrated, to not do that. So what was happening is it put the default, if I go back to my map and hover over 0, 0, so it's off the coast of Equatorial Guinea in Africa, where the equator and the Greenwich median come together. So that is, when you see features that you've added showing up in the middle of the Atlantic Ocean there near Africa, that's a sign that you haven't assigned the you haven't assigned that properly. You haven't assigned the latitude and longitude properly. So what I should have done, oops, is said PEE geometry, like is in the slide. So now let's see if this works a little better this time. Sure did. So there is the maroon square at the geometry that I defined here, somewhere in western New York. Any questions? What we'll do, we have a couple more slides on symbology. We'll take a break at that point, and then we'll start talking about rendering, which is related to symbology, but it's slightly different. So here's the slide that covers what we just talked about. Some of the key points, defining the marker using the two interfaces. Note the creation of the point geometry and the use of the put chords method. But shortly in the class we'll learn how to get a point from a user click. You'll do that in Lab 4 when you build your own identify tool. And then the last two lines, add to the graphics container and then redraw the map. Here's another symbology example. I'm not going to go through an exercise on this, but it's you have the slide. It's an example of using a character marker symbol instead of a simple marker symbol. With character marker symbol, you can take advantage of symbols that are located within TrueType font. And when you install ArcGIS Desktop, you'll get a series of TrueType fonts that start with the SRI. So here's in the picture. That's hard to see. That's a universal symbol. Some of the fonts here as Republic are often used on signage. So what's seen here, it's a symbol for a ladies' and men's restroom. And there's a whole bunch of other symbols. There's a trash can in there, and bus stop. Things you would often see on public signage are located in the ESRI Public TrueType font set. And there's a lot of, every release there's more and more. There's a lot, thousands of different TrueType font symbols with these character marker symbols in them for you. So a lot of this will be the same, but instead of using simple marker symbol, we would use I character marker symbol and character marker symbol class. Now we have to define the font we're going to use. The interface is I font disk, and the class, it's a little more where the class name is a little different than the interface name. It's I font disk and STD, standard for standard font class. And we need to cast it to I font disk in this case. The font disk property has a property name where you would put in the name of the TrueType font. And as I say this, I'm trying to think if it's just TrueType and not other types of fonts, but I believe that is the case. I think it has to be a TrueType font, which nowadays most things are. And you set the font size. Here I set to 48. Then just like before, there's no difference going forward. I'm setting the color just like we did in the demo. You can also create, if you're into graphic design, there are programs for creating your own font if you want to use a symbol that isn't located in any of the font types. ESRI font types are Wingdings is another standard Windows font, or Webdings that has symbols in them. You can use a program. No, I shouldn't even mention it because I did this almost 20 years ago. There's a program called Fontographer that let you build your own. What are the odds that still exists? We needed to make some custom fonts for Erie County Water Authority in 1998. It's still there. Probably a version or two newer. You can use a program like Fontographer. I'm sure there's others to create your own fonts. Our graphic artists use it to create their own text types. Like here too, our artists do that quite a bit. Here's a picture of someone making their own font from an artistic standpoint, but you could also use a tool like this to create your own symbols. So if you go to see Windows Fonts, there's actually a guy called, his name's Deja Vu. He has his own company. I'd say he sells, but he provides these for free. He has more free time than I. He created TrueType fonts for every root number in the United States by state. So I do quite a few projects in Pennsylvania, so I use this if I'm making a map in Pennsylvania. I use the actual shield. So there's a Pennsylvania Route 446 somewhere, so I can actually use that Pennsylvania-looking shield instead of just a circle. And it would have Interstate 81, Interstate 90, and so on. This is actually, things live on in a funny way. Oh, it's not showing up well. That's one of the fonts I created. Here's one for the water department in 1998. It still works. There were very specific symbols on their water maps that they really wanted and didn't want anything else. So that's their symbol for a hydrant. It's a circle with 3 tangential lines and a line pointing to it. So I actually use this to create a font with those symbols. I can tell that was pretty close. I created it on February 24th, 1998. Wow, that was a long time ago, wasn't it? I don't want to know where you were in 1998, or you'll lose points. But it's impressive to me that this works. I mean, TrueType fonts have been pretty standard. This file that I created in 1998 would work fine today. But here's these ESRI fonts. You see there's a lot. And if you click on them, you can see they have a circle with a shrimp in it, the NOAA icon. You might be getting my point that there's many available for you to use in these ESRI font files. ESRI elements actually have elements from the periodic table. A symbol for a mosque, a bus, and a boat. There's even my favorite. Where is it? Crime. There's all sorts of different criminal activity. There's dice for gambling, a martini class. I'm not sure why a golf club may be illegal to play golf. The police station and so on. A gun. Swearing is illegal in some places. So there's a symbol of a little halo with swear words in it. They tend to steal people's symbols. If they see people using a particular symbol that they made themselves, they'll ask people for the copy. So every release, this symbol set grows. Even crime scene of a body laying there. Symbols are pretty funny. A hypodermic needle. ArcMap's used a lot in police departments. So there's a lot of different symbols using character marker symbol. If you're a geologist, all the different symbols you'd see on a geologic map. I am not a geologist, so I can't explain these. I used to be able to. And so on. There's also a couple fonts with webdings and wingdings are not specific to Esri. These come on every Windows. Microsoft puts these out. It has some other symbology that you could use. An ambulance, a satellite, bicycle, and so on. So there's a lot of different symbols available. So once you do that, you add the symbol the same way as we added the point symbol. And here's our example. I chose that symbol represents a ladies' restroom. The only thing different is that I used character marker symbol and I assigned a font and a font size. A quick discussion on color, and then we'll take a break and talk about rendering. So the abstract is color, and then there's a different interface in class for specific definitions of color. And if you're a graphic artist, you would know all these. There's CMYK color, which is subtractive color, ink-based colors. There's RGB color, which we usually use, which is additive color for your screen. In an additive color, I don't want to get into cartography too much. In additive color, if you add color, it becomes brighter towards white. Subtractive color gets darker when you add color. Light is additive color. The lights here that are white represent all colors on the spectrum, all being displayed equally. If you add all colors on the rainbow equally bright, you get white in an additive color, which is what RGB is used to represent. CMYK would be something like ink or paint. Now we're going back to art class from high school, but if you took all the paints colors, mixed them together, you would get black. The more color you add in a subtractive color, the more it goes towards black. The more color you add in additive color, the more it goes towards white. There's a bunch of different types of colors. We will use RGB. It'd be cool if I had a red, green, and blue marker. But RGB stands for red, green, and blue. Those are the three primary additive colors. And each goes from 0 to 255. So the two opposite extremes would be, and RGB is represented with three numbers. 3 255s is white. all colors equally represented, 3 zeros would be black. 0, 255, comma 0, for example, would be pure green. There's no red or blue represented in the color. So if I click on my lines, I'll hit color, more colors. Notice with 0, 0, 0, they're all black. Just 255 only gives you a red. .255 0, 255 would be magenta. It's full red and blue without any green in it. And obviously there's a lot of different combinations of colors within that. It's like a off green. Equal values of the colors, but not quite 255 would be gray. So gray is when it's not black or white, but the three numbers are the same. That gives you a gray. And the higher the number, the lighter the color. So 0255 gives you a pure bright green, whereas 055 only choose a, or 120 will give you a dark green. And here's the interfaces for the colors I'm talking about. For simplicity, this isn't a class about cartography or color. It's about programming, so we'll keep this simple. We'll work with RGB color, like we already started to. We already looked at, remember, 10 slides or so ago, we saw how we can get those Windows colors using system.drawing.color. Here's how we could do the same with ESRI's color interface. So here we've created a new color object, just like we did earlier, and I can assign individual properties, red, green, and blue. So this is the different way I talked about. You might want to do this. I showed the former method first because it's simpler. I mean, there's all those named colors that you can just use. Sometimes though, you will get, and I have gotten this, you'll get specific requests from a client saying, I would like this exact color. And this is how you would do it. We've made maps for the American Planning Association where they do zoning maps. And for example, single family low density residential housing has a specific shade of yellow that they prefer on their maps. So they've actually given us RGB values and said we would like this exact color of yellow, or shade of yellow. And you could use this to do that. HSV is just another type of color where hue is the actual color. Color is saturated, completely saturated 100%, and is completely bright at 100. So these would go from 1 to 100, and that would go to 255. I'm not going to cover that other than this, but other than this to show you that it's just another way of defining color. Another way, this just shows yet another way. We looked at this already, where the color object in system.drawing lets us choose a specific named color like maroon or navy, magenta, Gainsborough, whatever. We never did find out what Gainsborough is. So we already saw this actually, but the Windows system.drawing.color class also has a from ARGB method where you can pass the three RGB values. So that will give you the exact. So here's the ESRI class way of getting the color using RGB, or system.drawing from Microsoft way of getting the color. They would both return the same color. We looked at this a couple minutes ago, but as in the system.drawing.color, a teleset shows you the available colors. This is the link to the Microsoft Windows help. Uncolor. In the Microsoft Windows system.drawing, and you can go through that and get a description of each. This is just a different way using hexadecimals. Web programmers will be familiar with this. Instead of 0 to 255, it's a hexadecimal number, way of representing the same thing that they're showing on the Microsoft page. And then this is, it's not very readable, this is another Microsoft chart showing what all these name colors are. I think that says lavender. My eyes aren't that bad yet. Okay, maybe they are. Lemon green, maybe. So on. So this is another, and there's the link that came on Google's site showing the name colors if you have an interest. Let's take a short break. I won't stray too far. We'll start up in a few minutes and finish talking about rendering.